Welcome to your first advanced chemistry video movie that goes along with probably some kind of exit ticket or document that your teacher's asking you to fill out. This is Math Skills 2.1. We're going to talk about scientific measurements. As you probably know from middle school that a measurement is a quantity that has both a number and a unit. We will continuously make the joke, no naked numbers. Numbers with no units next to them are meaningless to a scientist. In chemistry, you're going to encounter very large and very small numbers. So because of that, you have to become familiar with scientific notation. I'm sure you've learned this in mathematics courses before, but now we're going to use it pretty much every day. So it's a shortcut used by scientists to eliminate place-holding zeros. And it expresses a number as a product of a number between 1 and 10 only and the appropriate power of 10. So the way that works, the form of scientific notation is as follows. You'll have a digit to the left of the decimal, usually 2 digits to the right depending on the accuracy of the measurement, and we'll get into that in another video. All the other significant digits, those that are measured using a measuring instrument correctly, are written to the right of the decimal. That value is multiplied times 10 raised to a power of the original number, which has to do with how many zeros there are after or before the decimal place. Moving the decimal left gives you a positive exponent. Moving the decimal to the right gives a negative exponent. In modern notation, instead of saying times 10 to some power, we just say E and then the power. So this will be brand new for you, but you'll really like it if you have to type up your work. You don't have to use any superscripts. Sometimes it's easier to think if the number is greater than 1, the exponent is positive. If the number is less than 1, the exponent is negative. So here we go. Write the following in scientific notation. 6,500 becomes 6.50 E3. And let me go back and explain why. We've got a decimal place implied here. We're moving it 1, 2, 3 places to the left to get it into the correct format of a digit, dot, digit, digit, times 10 to the third, and we call that E3 instead because it's easier for us. 0.000345 becomes 3.45 e to the minus 5, exponent to the minus 5. The exponent is minus 5. 1, 2, 3, 4, 5 is where it lands to get it into this correct formula of digit, dot, digit, digit, times 10 to the minus 5 becomes e minus 5. And so on. We've got 500,000 becomes 5.00 E6 times 10 to the 6th. They both mean the same thing, but E6 is easier to say than times 10 to the 6th. And there's another one, 0.000000236. Get rid of all those annoying zeros that don't do much for us, and we get 2.36 e to the minus 7, or times 10 to the minus 7. So we're comparing times 10 to the 6th times 10 to the minus 7, and think about that very, very big number and that very, very small number. The very small number gets the negative exponent. So interchanging between scientific notation and standard numbers. We're given a number called 8.43 times 10 to the minus 7. We expand that into standard ugly notation, and we're going to take our decimal place from here and move it 7 places to the left to expand that out. Next one, 8.43 times 10 to the 7th, is the opposite. We start here and we move our exponent to the right so that we've moved it 7 times and we get the number here. It may help you to put your commas in. There you go. So then we've got 4.9 times 10 to the 12th. We expand that to a big fat ugly number. You can put your commas in every 3 zeros if that helps you understand the number. And 2.452 times 10 to the 0, well, times 10 to the 0 just leaves it at 2.452. What I want you to notice is this number has more digits after it. That means that this measurement was made using a very, very accurate instrument. Convert the following to standard numbers to correct scientific notation. These all will appear on your exit ticket. You might want to pause the movie to write your answers out, and you'll check them with your teacher in class. So go ahead and pause the movie. More practice. Check your answers with your teacher in class for these. Given these in your exit ticket, we're going to ask you to change them to standard numbers. That's expanding them to something ugly. And you'll check those with your teacher in class when it's time to go over the homework. All right, we want to talk about your calculator, the E button versus the caret. Contrary to popular belief, you can't always use the caret, times 10 to the caret, when performing calculations with a scientific calculator. It will work in Excel spreadsheets, but it won't work on your calculator. We will always use the EE, or just plain old E button on your calculator. So pause the movie for a minute, get your calculator out if you haven't done it already, and see if you can find your E or EE exponent button. It's very important that you know where that is, and if your calculator doesn't have it, pause this movie and go get a scientific calculator. You're going to need it for the whole year, and I don't provide them in the classroom. All right, so if you have a TA 83 or above, it's going to be something like this. You turn it on, and then you make sure it's clear, and then you want to go to your mode. The mode has to be in float. So set the mode to float, quit using the arrow buttons if you need to highlight, get it into float mode. Type in the value that you're interested, like it's 8.33. Then type in the second button, and then the E button, and then the power. So once you've done it, 8.33 second E3 will show up as 8.33 e to the third power on your calculator. Once you've done that, you can add, subtract, multiply, and divide correctly in this class. So try the following calculations using the x times 10 to the caret button, and compare your answers on your exit ticket for these 4 problems. Pause the movie, write these out, run the calculations on your exit ticket, and we're going to talk about this in class. Always use the E button. Now we're going to talk briefly about units in the metric system. It's a form of measurement we use in science. You know this since 6th grade at least. It's used because it's simple. The units are in base 10. Scientific notation works really well with it because it's about powers of 10. It's called the International System of Units, or SI for a Système International in French. So there's 5 base units. You need to get these down. You need to know that the base units we use are the meter. It says kilogram. Let's just call that gram. Kelvins for temperature, seconds, and moles for amounts of matter. So we'll be converting between these. All right, so once we run through some calculations, let's take a minute, pause your video, do these calculations, and you'll be able to check your answers on the next slide. So pause the movie, do these on the exit ticket, and then advance. And here are the solutions to the problems that you did. Hopefully you're using your calculator correctly. All right, so we're going to see you in class, and if you have any questions, it'll be a really good time to have a conversation.